Good morning, student. Now you open your page number 86. We completed till representative element main characteristic. Now the next point, a transition element, which are the D block element. Transition element, which are the D block element. I'll show you how it's look like. These are the D block element. Okay, so in this characteristic of the element, they are included in a group 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 13th. This group are this number of group are known as a transition element. So the main characteristic of this group is the first main characteristic is all these elements are metals and with high melting point and boiling point, which means that very strong metals are there and they have a very high melting point and boiling point. Okay, so for example, copper, gold, platinum, all are present in this group. Iron, like that. Then the second point, they are good conductor of heat and electricity. Those metals which have a high melting point and boiling point, and those metal which have a good conductor of electricity and heat, they are present in a transition element. Next one, some of these elements are attracted towards the magnet, like Fe. You know this Fe. Fe present in this. Okay, that is a group number 8. In group number 8, Fe is present and they attract towards the magnet, that you know very well. Next one, the most of these elements are used as a catalyst. Now you know what is the catalyst. Catalysts are used in a chemical reaction to increase the speed of the reaction, rate of the reaction, which are known as catalysts. So that this element and this group elements are mostly used as a catalyst. Next one, the E, most of these elements exhibit a variable valency. Variable valency, which means that the more than 2 valency or 2 or more than 2 valency, like Fe, Fe plus 2, Fe plus 3, Sn plus 2, Sn plus 3, Ag plus 1, Ag plus 2. So some of the elements have a variable valency. So most of these elements exhibit a variable valencies. Okay. Next one, the most of these elements form a colored ion and colored compound. Colored ion and colored compound, which means that when this particular element form a compound, and that compound have a particular color. Okay. For example, copper sulfate, CuSO4, they form blue color. Copper nitrate, they form green color. Okay, Fe, FeCl2, FeCl3, yellow orange color. So this is the way this compound can able to form a different color. Okay, so some of the compound can able to form a color. So these are the main characteristic of the transition element. Only this much thing you need to know. Don't go more deep in this transition element, because more than this it will not come in your syllabus even in 10th standard. Got it? Now the next, that is the inner transition element, which are the F block. This F block, the full F block are inner transition element, lanthanide and actinide. So let's see what are the inner transition element. The element of the 6th and the 7th period of the group, 3rd, that is a lanthanide, and the actinide are the collectively known as inner transition element. This D block are transition element, F block are inner transition element. Okay, remember this thing. The name only you need to remember. Now the main characteristic of this group is, these elements are that first, they are very heavy metal and with high melting point and boiling point. They are very heavy metals. All are the metals you can able to see in your book on page number 83. All are very heavy metals. They show a variable valency just like a D block, as I told you. They form colored ion, okay, as I told you before. Next one, The actinide are all the radioactive element and some of not found in nature, which means that the actinide here are the radioactive, like uranium. You heard about uranium 92. Although you don't aware of this, but in a day-to-day life, uranium and thorium, you heard about that. So that uranium and some of the element are radioactive. They generate a radiation. Okay, so some or some of the element not found in nature. They are man-made. They are made in a special laboratories. Okay, so you know that out of 118 element, there are 93 are natural occur and remaining are produced in a laboratory by man-made. So these are the elements. Okay, so I hope you understand till here. Now the other thing, next point, that inert gases. So the inert gases, about the inert gases, here it is. Wait a minute. Inert gases. The element of zero group, which is the 18 vertical column, are known as the inert gases. Okay, that you know very well. Inert gases like this. These all are the inert gases. Helium, neon, argon. And why they are known as inert gases? Because I told you they have completed their electronic configuration. There is no valence electron present in it. All octet are completed and helium have a 2 electron, very fully satisfied with the places occupied by the electron. So that is why it is known as the inert gases, and they cannot react with anyone. So they have 8 electron in their outermost orbit, except helium, which has only 2 electron. So they do not react with the other element and are therefore inert. Okay. So here till here we learn about all the elements, all the blocks of the periodic table. In this periodic table we learn this is the S block element, this P block element, and P block and S block element. S block and P block element known as a representative element. These are the P block element, which is known as a transition element, and these are the F block element, which is called as the inner transition element. And you can see this, here the metal, these all which are the blue in color are metals. These are known as a metalloids. These are known as a metalloids, which have both the property metal like and non-metal like. And these are the non-metals, and these are halogens. Okay, non-metal halogens. And inert gas is also non-metal, but they are not react with anyone. So we learn about the overview, we learn about the periodic table, and the overview and the overall property, average property, physical property we learn about. Okay, not in full detail. So from this, here some notes are given. That bridge element of those secondary periods, so the resemble in a property with the element of the next group of the third period, leading a diagonal relationship. Such an element called bridge element, like a lithium and magnesium, beryllium. Here it is given, but I will show you here in this. What exactly they are telling? That a lithium have a diagonal relationship with the magnesium. This lithium have a diagonal relationship with the magnesium, which means that the some property are matched, little bit, not more, but some property are matched with this magnesium. Lithium, some property are matched with the magnesium. That is the first. So that's why it is known as a diagonal relation between lithium and magnesium, because it is diagonal. Okay, and which one is the other one? Beryllium and magnesium. Beryllium and magnesium, here it is. Sorry, beryllium and aluminium. Sorry. So here that also. So that is the relation. The boron and aluminium also. So that some relation are given. Beryllium and aluminium. Then the boron and silicon, here it is boron and silicon, boron and silicon, this diagonal relation, beryllium, this beryllium and this aluminum. So this is also a, so if we remove this, then it join and it become like this. So that is the relation. So which is called a bridge element. These are the bridge element: lithium, magnesium, beryllium, aluminum, boron, silicon. Why? So about more detail, which property are related, which property are similar, which property are different, that you will learn in higher standard. Right now just need to know only about this much, that these are the bridge element, which is meaning that they have some similarity in their property. Okay. Now the next, the typical elements. The third period element: sodium, magnesium, aluminum, silicon, phosphorus, sulfur and chlorine. This element are summarize the property of the respective groups, which means the sodium in a first group, magnesium in second group, aluminum in a 13 group, silicon in a 14 group, phosphorus, sulfur, chlorine. These are the all the main property is present in all this element of each group. So this element known as a typical elements to summarize the property of the respective group. If we want to know about the full group, if we know the property of the sodium, then we can able to find out the other element property also. So these are, we can say, the representative of the group, like a sodium. So other also are, we can say, the representative. So typical element we can say. Okay. I hope till here you understand. If you have any query, then you ask. Okay. Now let's learn the next point, the merit of the modern periodic table, which means that what are the advantages of this modern periodic table, modern Mendeleev periodic table. First, it based on the atomic number. Now we know very well it is based on atomic number, increasing order of atomic number. So which is even better fundamental property, which means that if we know the atomic number, we can able to find out the property. Suppose the sodium. Okay, so sodium, we know the sodium that is atomic number 11. Sodium atomic number is 11, that we know very well, right? So because of we know the atomic number, we can able to find out the electronic configuration 281. Now we know the atomic number, we can able to find out the electronic configuration. So little bit we can know that okay, this is the one, which means it is present in a first group, and first group have a different property. So it is more convenient if all the element are arranged according to their atomic number. Clear? So that is why it is a more advantageous. Next one, so the better fundamental property compared to the atomic mass. Second point, the position of the element in the table is related to its electronic configuration. Okay, so here the position is given, the particular element have a position given, that a position through we can able to find out the full electronic configuration. Like suppose ki one of the element put in a first group second. Okay, so first group second, that is a lithium. So through electronic configuration we can correlate the electronic configuration and the position, and we can able to find out the particular element property and characteristic. So it is more convenient. So that's why it is a merit. Third, it shows the regular change in a property of the element on moving across the period or down a group. So it's a regular change in properties of the element on moving across the period. Moving across the period, which means that in a periodic table, when we move from left side to right side, which is meaning of the moving across the period. And if I talk about from top to bottom, which is called moving across the group. So the regular property are changing. From across the period as well as down a group. Okay, which property are changing in regular interval, that we will learn in a next video. Okay, now the modern periodic table is easier to remember, the understand and the reproduce. The modern periodic table is very easier. We can able to remember the most of the element position and name and characteristic and property, and understood and reproduce also. We can able to write our own self some of the element position. Okay, so that is why it is a very useful thing. Now what are the demerits? Demerits are the first, that is the position of the hydrogen, that I told you before. The position of the hydrogen is still nowadays it is a controversy, because the some of the characteristics are related to group 1 and the some of the characteristics are related to group number 17. So that is why it is, that is a first defect or demerit also. Second point, if fail to accommodate the inner transition element lanthanide and actinide. As I told, as we learned that the F block lanthanide and actinide are kept aside out of the box, which means that it have to be come into the D block, but they have provided the other row, which is F block. So that is considered as a demerit or defect. Okay. So lanthanide and actinide into the main body of the periodic table. So lanthanide and actinide are removed from the main body of the periodic table. So that is also a demerit which is considered. Okay. So these are the merits and demerits. Now the general trend in the modern periodic table, general trend, which means that a group trend and a periods trend. So first we learn the groups, the number of cells and the valence electron. From groups what we can able to find out. So first the number of cells and the valence electron. Okay. So the number of cell increase arithmetically, the number of valence electron remain equal to the number of group to which the element belongs, which means that lithium, sodium, potassium. So the lithium have a 3 electronic configuration, sodium 11 and the potassium are 19. Okay. So electronic configuration 2 1, here 2 8 1, here 2 8 8 1. So this trend are similar but equal interval. So in this group have outermost electron same 1 1 1. This trend are similarly changing, regular interval, so it will changing. So what is the number of cell increase arithmetically and number of valence electron remain equal. Number of cell increasing, 2 cell, 3 cell, 4 cell, but the outermost electron remain equal in a group. So to the number of group to which the element belongs. Okay. Also number of electron cell in a given element, also the number of electronic cell in a given element equal to the number of period to which it belongs to, which means that the number of electron cell in given element equal to the number of period, which means that here that suppose here 2 cell, which means it is second period, 1 2 3 cell, which means it is third period, 1 2 3 4 cell, fourth period, and so on. Okay. So number of cell, we can say here number of cell are given us a particular number of period. So first period have a hydrogen which have a 1 only electron, an atomic number, so only 1 electronic configuration. So the 1 cell only, so first group, second 2 cell, okay, and so on. So this number of cell represent the number of period. Which period? This particular K, potassium present in a fourth group, fourth period, first group. This is the way we can say. Okay. So here some examples are given in your textbook like halogens. So halogens also. So halogen 2 7, 2 8 7, 2 8 18 7, 2 8 18 7. So here the outermost same number of cell here 2. So second period fluorine, chlorine second period, third period bromine, fourth period iodine, okay, antimony. So this is the way the number of cell are cell represent the number of period. Then the valency. The valency of an element equal to the number of electron present in its valence cell. So since the element in the particular group have an equal number of electron in their respective valence cell, So valency of the element in the given group is the same, which means that here if this is the way the valence, here you can see, you can able to see all these three have a 1 1 electronic configuration. If you find an outermost cell is considered as a valence electron. So here the 1 1 1 electron in valence cell. Okay, now for the here, so the valency of the group first element is 1 2 and 3, that you know very well. Okay, now after the fourth, the valency of the fourth group, valency of the fourth group, here fourth group, fourth A, this. Okay, so this fourth group, fourth A, so its valency is +4. Now after the fourth group, here the fifth, so 5 minus 8. Okay, what we can say, 5 minus 8, so how much, -3. So a nitrogen group have a this group have a -3 valency, 3. Then 6, so 6 minus 8, so here 6 minus 8 -2, this 7, so 7 minus 8 -1. Okay, so the nitrogen family have a -3 valency, oxygen family have -2, fluorine have a -1 valency. So this is the easiest way to remember what is the valency of the particular group element have. Okay, and if you do not remember this Roman name, then through this also you can able to find out. Okay, how that here till here it is after the 8 number, here 10, so you have to minus 10. 10 minus 3, 3. Okay, like this. Here it is given in your textbook. 13 minus 10, 3. 14 minus 10, 4. 80, and after the fifth group, 18 minus 15, 3. 18 minus 16, 2. 18 minus 70, 1. But I think that it is a little confusing. Instead of that, you can memorize like this, that a fourth group, like you can see that after the fourth group, fourth A, which have a 4 valency, plus 4 or 4 you can write only. Okay, now the fifth A, which means that this is the 5 minus 8, so 3 valency, -3. Then a 6A, so 6 minus 8, -2 valency. 7A, 6 minus 8, sorry 7 minus 8, -1, so -2 -1, so this is 7, 17 group. 6A, 16 group. 5A, 15 group. 4A, 14 group. 3rd A, 13 group. Okay, so here 3 valency, here 4 valency, -3, -4, -1 and 0, because 18 group. So this is the easiest way you can remember. Okay, about first A and second A you know very well, 1 and 2. Okay, so 1 2 3 4, have you understand this? So this is the way you can calculate the valency of the particular element of this group. Okay, if you have any doubt, then ask. Okay, now I hope you understand all this, how to find out the valency from the group number. Okay, now a property of the element. Next, property of the element. The element in a given group possess a similar electronic configuration, that you know very well now. So because of the number of electron in their respective outermost cell is the same. Remember student, every time the in a group, all the element have a same outermost electron. Like a first group have a 1, second group have a 2, so on. So because of they have a same number of valence electron or outermost electron, they can possess a similar type of physical and chemical property. So they have a similar physical and chemical property which change uniformly down the group, matlab down the group, top to bottom, first element to last element in a group. Okay, so first element to last element, which means that here the first group 1, in a group 1, hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. So this is called a down group. So in a regular interval, they are changing their properties. How? Which properties are changing? So let's see the different property in this type of groups. So first, some common property first we'll learn. Here it is given. Alkali metal group 1 are very reactive and degree of reactivity further increase down the group, which means that we can say that here from top to bottom, reactivity increases, which means that the lithium from between lithium and sodium is more reactive. From sodium to potassium is more reactive. Okay, so the francium is a more reactive. So this is the way. So lithium से ज़्यादा सोडियम से ज़्यादा पोटेशियम से ज़्यादा रुबिडियम और रुबिडियम से ज़्यादा सीजियम. इस तरीके से the reactivity from a down the group is increased. Okay, so reactivity increase. Remember this thing. Now in halogen atom, halogen, which means, which are the halogen? Fluorine, chlorine, bromine, iodine and antimony. So these are the halogens. Halogen 17th group. So but the degree of the reactivity decrease as move from fluorine to iodine, which means that from top to down in this group the reactivity is decrease. Remember. Okay, remember this too about alkali metal reactivity increases, halogen metal reactivity decreases. Clear? Second point, atomic size. As on moving down a group, size of the atom of successive element increase. Okay, size of the, here it is represent, you can see this. As I told, here the number of cells are increased. Here the number of cell 1, here 2, 3. So I'll draw here 1 cell, here 2 cell, here 3 cell. Okay, in a potassium there are 4 cell. In rubidium 5 cell, like this. So here it is given proper way in your textbook. The size, cells are increasing. That is why the shells are increasing. So that is why the size is increasing. So we can say that reactivity increasing as well as size also increases. You can write with me like this. The reactivity increase in the number of cell. For example, group 1 atomic size increase as one move from the lithium to cesium. So size is increasing. Here also, not in this, here also, in halogen also, it is not given, but here we can say that a size increase. In this case, about size, in all the group, number of cell are increasing from top to bottom. So in all the group we talk, then from top to bottom individual group if we take, then every single group from top to bottom the size is increases. First group size also increase, second group size also increase, third group, so on. Okay, size is increasing. Now the metallic character. The metallic character increases. Here first I am writing the metallic characteristic also increases. Okay, metallic character increases as one move down a group. For example, in group 15, here also the metallic character increases. Here in your textbook it is given the 15 number group example. So let us take a 15 number group, which are the nitrogen, phosphorus, phosphorus, As, Sp, arsenic, what is Sb? Bismuth, like this. So here from the down the group, the metallic characteristic is increasing. Metallic characteristic increase. Okay, metallic characteristic increase. Okay, so metallic characteristic increase here though. So the group 15 nitrogen and phosphorus are non-metal. Okay, so here first two are non-metal, these are the non-metal. Okay, then these two are metalloids. What is the metalloids? Both the property which have. So metalloids, metal like property also present and non-metal like property also present. And then this bismuth is a metal. So non-metal to metal, that is why we can say the metallic characteristic is increasing. Non-metal to metal, which means metallic characteristic increasing. So antimony, here the non-metal, arsenic and antimony, this is antimony, Sb is antimony, are metalloid, and the bismuth is a typical metal. Okay, so it is on account of the gradual increasing in metallic character of the element from top to bottom, the oxide of the element become increasingly basic in character, moving the same direction. Here it is given that now the oxide which means that nitrogen oxide form NO2, phosphorus P2O5, here arsenic As2O3, Sb2O3 and Vi2O3. So all this oxide form, first two are acid, first two are in acidic form, then second two are amphoteric, which means that both the property, it be sometime behave like acidic and sometime behave like basic, that's why it is amphoteric. Okay, and the last one, that is a bismuth, which are considered as a basic characteristic. So acidic to basic, so we can say that increasingly basic in character, moving the same direction, which means top to bottom. Here the last is a basic, so acidic to basic, which means the basic characteristic is increasing down the group. Okay, have you understand this metallic non-metallic atomic size property? Okay, so now here the hydrogen has here note is given that about the hydrogen, that you read that the hydrogen has been placed at the top of the group, reason behind that, so that here it is given that you read yourself. It is very easy, and so many times we already explain about the hydrogen controversy, the place where it is put. So that is given here. Okay, so now the next one in a next video.